Yeah, hello, good evening everyone. Am I audible? Okay, I think I'm audible to you. If not, then please let me know. हेलो हेलो। हाँ, अरे मैं मीटिंग ले रहा हूँ अभी वो क्लास में। Yeah, I think there is some internet issue here. Wait a second. I think it is fine now. Is my screen is visible or not? Yeah. Yeah, there was some internet issue. I'm really sorry for that. Hello, is it fine now? Am I audible to you? Why it is? Okay, I think we can start now. If everything is fine, then please someone write in the chat box if screen is visible and I am audible as well. Can we start now? Anyone please reply.
Yes, yes.
Okay, okay, thank you.
Start, sir.
Yeah. Okay, so today we are going to start our week 8 assignment. I hope you have completed all the lectures. So have you completed your lectures?
Yes, yes.
Okay, great. So there are some questions from assignment 8 that will be taken by me, and the rest of the question will be taken by other TA tomorrow from 7 to 8 p.m. I hope you know already. So this is the question 1 related to this assignment. It says, amongst the following synthesis methods, which belongs to the top-down approach? So if you have completed your lectures, then you must have seen this synthesis technique chart. So here there are two kinds of approach, bottom up and top down. So in case of a top down approach, we have mechanical milling. It is also known as, yes, Kanchana, you are right, ball milling. And second, we have nanolithography. It is also a top down approach. So C and D are the correct answer here. C and D. Kanchana, you are right. And one more, nanolithography is also there. So let's move to the next question. It says, using a carefully chosen synthesis protocol, one can obtain materials with tune. These are the options. Means if we are using any synthesis protocol carefully, then which properties of material we can change or desired changing in the material property we can get. So you just need to tell me those properties which you can change while synthesizing any material. Oh, already answer is here. Yeah, Kanchana, D. So morphology, porosity, inner cavity, all of the above. So here you can see from the lecture only, by choosing the proper synthesis protocol, we can tune morphology, then yes, surface area, porosity, yes, inner cavity, yes. So all three, then all the above. So the answer of this question is D. So let's move to the next question. It says, in a 3-electrode measurement, to determine the electrochemical performance of active material, the counter electrode is constructed using. First tell me name of 3 electrodes. 1, 2 and 3. Name them. 1 already is here, counter. What are the name of other 2 electrodes? Cathode, anode, electrolyte. No, Kanchana, that is not. There are names of electrode. Actually, you are telling me the components of the battery, but before construction of a battery, there are some methods by which we measure the electrochemical potential of any electrode. So for that purpose, we use this three electrode measurement. Yes, Kokila is right. One is reference electrode. So counter, reference, and okay, it's fine. So these are the options. You just tell me the counter electrode is constructed with what material? And third electrode name will be here only in the answer. Metal. So Kanchana, are you saying counter electrode is constructed using metal? I think yes. Okay, it's fine. The name of third electrode? Working electrode. So these are the three electrodes: working electrode, reference electrode, and counter electrode. And this working electrode is made of active material. This reference electrode is made of AgAgCl, and this counter electrode is made of platinum rod. Yes, Kokila, working electrode was the third one. Great. So answer here will be platinum electrode. Yes, answer C is correct. Now let me know the function of this counter electrode. Why we are using this counter electrode? Nobody knows. It's fine. I'll show you. So this is the counter electrode. This is made of platinum metal or platinum electrode, it is also known as. The main working of this counter electrode is to bypass the extra electron generated during electrochemical reactions. So it is helping to take away the extra generated electrons during a chemical or electrochemical reaction. So it is countering. Okay, fine. Let's move to the next question, which says, in an electrode, how does the specific capacitance change with the increasing scan rate? Very simple question. It is asking the value of specific capacitance with increasing in the scan rate will increase, decrease, equal, or does not affect. These are the options. It increases, decreases, remain constant, or cannot be predicted. With scan rate, the specific capacitance will increase, decrease, remain constant, or cannot be predicted. Specific capacitance increases according to Kanchana. Okay. Kokila saying decreases. Okay. So Kokila, you are right. Actually, you can think this question like, if there is anything and there are many cycle, so the properties of that thing will reduce or it will affect negatively. So here also specific capacitance will decrease with increasing in the scan rate. How can we see? See, this is a chart. This is the real chart which like you obtain during any electrochemical reaction or during any experiment. So this is the specific capacitance y-axis, and here x-axis is the scan rate. So with increasing in the scan rate, the specific capacitance is decreasing. So yes, B is the correct answer. Kokila is right. It will decrease. Let's move to the next question. It says, in impedance analysis of a supercapacitor, the first intercept of the Nyquist plot with the real axis can give information about. Very simple question. If you know about this Nyquist plot, so these are the options. For like rough purpose I am showing, if this is a graph and according to this Nyquist plot we write impedance real part, impedance imaginary part. Okay, so it is asking if anything is here, like this is the chart. So first intercept is this one. So this value represents what? Equivalent series resistance, charge transfer resistance, contact resistance, or internal resistance. See, in this question you can eliminate the options very easily. How? It is saying equivalent series resistance. So contact resistance is already here, internal resistance is already here. Because it is saying equivalent means total, everything is included. So what options are left? Just A and B. So from A and B, if you don't know then guess. Let's see your luck. Okay, Kanchana saying A, Dr. Narveer Singh saying B. I am saying just guess. What about others? Choose one, A or B. What about Kopila? Okay, she came. Equivalent resistance. Yes. Now let's see. This is our Nyquist plot, and here we can see this part R ohmic. We are asking. I just told you we just need to find our answer from A and B. B is saying charge transfer resistance, which is already here. So charge transfer resistance will be this one. But question is asking first intercept. First intercept is this one. So question is asking this resistance. So this is ohmic resistance. And ohmic means here series resistance. So option A is correct answer. Equivalent series resistance. So yes, guess from Kanchana and Kokila are right. A will be the answer here. Let's move to the next question. It says the activation energy for a specific reaction depends on. Very simple. The activation energy for a specific reaction depends on. I hope you already know what is an activation energy. Do you know? Yes, no? S means yes. Okay. Okay. So you must have some idea about this activation energy. So these are the options. So on what it depends on. So does it depend on concentration of reactant, temperature, catalyst, or porosity of final product? Here you can eliminate one option directly. Yeah, great. Kanchana said A, B, C. Dr. Narveer Singh said A, B, C. So you have a good idea about this activation energy. Great. Yes. Concentration of reactant, temperature, and this catalyst. These three are the correct answer, not this 4-1, porosity of final product. Because product, nothing is dependent on product here. Because activation energy is before the product formation. So we can eliminate this one. So yes, A, B, C are the correct answer here. Let's move to the next question. So this question is very simple. If you know the graph of cyclic voltammetry, or if you have any idea about electrochemical reaction, then nothing is there. It says based on cyclic voltammetry, choose the correct. So these are the options. Oxidative reactions takes place, or anodic current take place due to oxidative reaction. Cathodic current take place due to oxidative reaction, or anodic current take place due to reductive reaction, or cathodic current take place due to reductive reactions. And for your kind information, this current is anodic and this current is cathodic. So you just need to tell me this forward scan, is there oxidation or reduction, or here oxidation or reduction? This anodic current is due to oxidative reaction or reductive reaction. Is here oxidation taking place or reduction taking place? Kanchana, Dr. Narveer Singh. Dr. Narveer Singh saying A and D. Kanchana saying A. Okay. Kanchana, your name is Kanchana or it is Kanchan? Loss of electron oxidation. Okay. Yes, you are right. Option 1 is correct. No, actually I'm asking pronunciation about your name. I'm saying right, or I'm saying like I'm adding one A or Okay, what about others? So yes, Dr. Narveer Singh is right. Option A and option D are the correct answer. Oxidative reaction are induced by anodic current. So scale is positive, while reduction reaction occur at negative scale. So here it is reduction reaction. A and D are the correct answer here. Let's move to the next question, which says identify X and Y. This is the X and this is the Y. Very simple question from I think 9th standard. Okay, options. Okay, these are the options. Then choose here from here. I think now you can answer easily. X reactant and Y products. Kanchana is saying reactant and product. What about others? Are they satisfied with this X and Y respectively? Yeah, Kanchana, you are right. X is the reactant and Y is the product. B and C. Yes, Dr. Narveer Singh, B and C. So B and C are the correct answer here. So let's move to the next question. This question is the second last. After that, we will have one more question based on this question only. So listen carefully. So here identify the correct option. This is one activation energy. This is second activation energy. And this is the chart ln K versus 1 by T. You just need to tell me which option is correct. Is activation A is more than activation B, or is it opposite, or both are equal, or none of the above? A, B, C. Because there is no chance about D. So A, B, C. Choose among these three. C. Okay. Kanchana, just remind yourself with the Arrhenius equation and then try to make a graph ln K versus 1 by T. EA is greater than EA2. Kanchana is saying first C, then she changed. It is saying now she is saying A. Okay. And if you have solved this question, then please ready with calculator. Next question is based on some calculation. Only one answer for this. Oh, Dr. Narveer Singh, A. Okay. Kanchana, yes, slope. More the slope, more will be the activation energy. Because slope is EA by R. Yes. Option A is the correct answer. You can see this is the Arrhenius equation, and we can write this equation by taking log this like this. And if we will plot this equation, ln k versus 1 by t, y equals to c minus mx. So here m is the slope equals to Ea by r. Straight line equation. So this slope is showing Ea by r. So more the slope, more will be the activation energy. So slope of A is more, or slope of 1 is more as compared to slope of second. So yes, A is the correct answer. Yes. Next question. It says at a temperature 600 Kelvin, the rate constant is given 2.75 into 10 raised to the power minus 8 per mole per second. And when the temperature is increased to 800 Kelvin, this rate constant is given as 1.95 into 10 to the power minus 7 per mole per second. So you just need to calculate the activation energy of this reaction based on Arrhenius equation, and these are the options. Take your time, I am waiting. If you haven't understood, let me know. Two different temperature, two different rate constant. Just need to calculate activation energy. If you need formula to calculate, if you need any help, I am here. But I want you to solve this. Two more minutes. Should I solve it? Yes, no. Are you having any difficulty? Yes, okay. See, This is the Arrhenius equation. Just take log both sides. So this equation we have here. K is the this rate constant, and EA is the activation energy. We need to calculate this activation energy, and for this reaction this A will be constant. So just write the given of this question like this. It is given T1, T2, K1, K2. Simple. Then just subtract one equation from another. How? ln K, write it is as ln A minus EA upon R T1, and ln K2 minus or equals to ln A minus EA upon R T2. So this equation 1, this equation 2, just subtract 1 from 2, then you will have ln K1 minus ln K2 equals to, so this one will be cancelled, minus EA upon R T1, 1 upon T1 minus 1 upon T2, and this ln K1 K2 you can write ln K1 divided by K2. So same this equation, you can get this equation, and here just need to put these values K1 K2 R1 T1 T2. R1 write 8.314. Now calculate it. K1 K2 you know already, T1 T2 you know already, are given by here, already given 8.314. just need to calculate activation energy. Are you calculating? Yes, no? If not, I can show you the further calculation as well. Okay, so I am showing. So just putting this value here, you will get EA equals to 39089 joule per mole. So here A 39089 is the B. So B will be the correct answer here. You can try this question at home as well and see where you are making mistakes. So we are done with today's lecture. Next we will meet next Friday with week 9 assignment. Thank you everyone for attending this, and I am happy today's class was like a bit interacting. Yeah, thank you everyone. I want others also to respond during the class, so it will be very interesting. Even you will learn a lot. If you are making any mistake while answering some questions, doesn't matter. Nobody is going to judge you here. If you know, then yes. If you don't know, then try. Okay, have a nice day. I am ending this meeting. Yeah, take care. Bye bye. Yeah, thank you everyone.